All right, so we are talking about the Oswald dilution law and dissociation constant. Now we said consider a weak acid HA of concentration C mole per dm cube and degree of dissociation alpha. Now I said earlier, if you were listening to that earlier lecture, that if we consider C as the concentration of the compound in consideration, alpha is the fraction of that compound that has dissociated. What did I say? Alpha is the fraction of that compound that has dissociated. Now, the whole compound, the entire compound is indicated with 1. So when we talk about the total amount of the compound is indicated with 1. Alpha is the fraction that have dissociated. The entire concentration is indicated with 1. So if we have C as the concentration, you can now say C is what? 1 minus alpha is the fraction that has what? Dissociated. Take note of that. So if you want to know the amount that have actually dissociated at any point in time, you are now going to say C bracket 1 is the whole compound minus alpha is the fraction that has what? Dissociated. Is that okay? So the whole compound at any point in time is indicated with what? C times 1. And of course, C times 1 will give us what? C. So that is that. Now, instead consider a weak acid. You can see the equation here, which is HA coming here, going there to give us H plus what? A negative. Alright? Now, HA is the concentration of the acid. Now, before the reaction starts, initially, listen, this is very, very important. Initially, the concentration of the acid still remains the same. That means the weak acid still remains the same. Recall that it is a weak acid. Now, because it's a weak acid, you don't expect all of them to dissociate. You only expect partial dissociation. You only expect what? Partial dissociation. Very, very important. Is that okay? You only expect partial dissociation. Very, very important. You only expect partial dissociation. That is why we have to represent it with what? The fraction that dissociated. So initially, before the reaction starts, the concentration of C still remains C. I told you that the whole mole, the whole concentration is actually indicated with C bracket 1. That is the entire concentration. Where 1 is like it is complete. U1, you are complete. So C bracket 1. Now at that point, initially, when the reaction starts, the substance have not started dissociating. So it means no H plus ion is formed and no A negative ion is formed. So that is why you see that the concentration of C still remains C. The concentration of H plus remains 0. Concentration of A minus remains 0. Why? Because no H plus is formed and no A negative is also formed at this point in time. Is that okay? Exactly. Now, but as time progresses, at equilibrium, when we talk about equilibrium, it means that the rate at which HA is converting to H plus and A minus is equal to the rate at which A minus and H plus is coming back to what? HA. What do we mean by that statement? It's a very simple thing. HA dissociate to give us H plus and A minus. Now, as time progresses, the time will come when these two now will now start reacting backward. That's why we say we have the forward reaction and we have the backward reaction. So initially it is only HA that is dissociating, then H plus is formed. It's gradually building. A time will come where H plus and HA now will now start reacting to give us HA back. That point at which the rate at which this one is converting to this is equal to the rate at which this side is converting to this, you say that the reaction is at what? Equilibrium. Is that okay? It's more like you have a small room here, a classroom, and you have, let's say, 10 people. Now listen, the 10 people are supposed to come into this other room here. Now, of course, when you say everybody move, not everybody will move at that time. Some will carry their bags, some will be talking to their friends and so on. A time will come where some people are already here. Are you getting it? Now, when some people are coming here, and let's say the reaction will be such a way that some will come here and they come back. Now you discover that when the reaction first starts, there's nobody here. True or false? That is why we say that at the initial time, let's say the concentration is 10, which is 10, there were no thing at the product side. But as time progresses, one person, the first person moved, so here will become 1, here become 9. The other person moved, here it's become 2, here will remain what? 8. The other move, here become 3, here become 7. Now a time will come where some of this one here will start coming back again. So when one leaves here, come to this place, here maybe now becomes 9, or let's say 8, while here will be reducing. But a time will come when the amount of people actually coming from here to this place equal to the amount of people going back to our initial position. You say that that time the reaction has come to what? Equilibrium. Is that okay? So at equilibrium, what happens is, I told you that alpha is the fraction. When you talk about the fraction, for instance, if you say this is a house, I mean this is bonds, or let's say this is bonds. If you want to talk about the fraction of bonds that somebody cut off, what are you now going to say? You may say half. You cut half of the full bonds. Abi, how do you indicate the half? You indicate the half by saying half of the bonds, which is half B. Are you getting it down? So if we say this is the concentration, the fraction that actually left is what we indicate with alpha. So if we want to talk about the fraction that left, we now say alpha C, or C alpha is what left. This is very, very important you understand this. I'm taking my time to actually explain this because I know it's very, very difficult for some of you to really understand what I'm trying to say here. I'm taking my time to explain this. Look at it. It's very easy. Somebody give you, you borrow somebody money. You borrow somebody 10,000 naira. Yeah, right? You borrow somebody 10,000 naira, 10k, and then the person give you 5k after much trouble, calling and so on and so forth. Now, at the end of the day, if they ask you how much this person don't give you from your initial money, you go say, now how much you be given? 10k. How much he don't give you? Say, now half of the total money that he give me. Half means what? Half of total money is what? 10k, which is half of 10k gives you what? 5k. That's what we are still trying to say here. That if the total concentration of the acid is C and alpha is the fraction that was dissociated. Now look at it. I told you that the fraction that is dissociated is given by alpha. If alpha is the fraction that is dissociated, we will now want to calculate the amount that have dissociated the total. You can now say that is the fraction times the total amount, which is alpha times what? C, which is C alpha. So you can say C alpha. Anything that happens here must also happen here, but you must take note of the mole ratio. So the mole ratio is 1:1. So the amount of this, this one is the one that will dissociate to give us this and this. True or false? So as this one dissociated, the amount of this that will be formed is also equivalent to the amount of HA that will be what? That will be formed. Is that okay? So you are now going to have C bracket 1 minus alpha. If you want to express this is going to give us what? Because C times 1 is 1 minus alpha, which is what? C minus alpha. Now this alpha C is telling us the fraction of the entire concentration that has dissociated. Do you get it now? The amount that has dissociated is giving us what? Alpha C. That amount now, or C alpha, whichever way you want to place it, you can say it's what? C alpha. Then this one is also C alpha and what? C alpha. Is that okay? So at equilibrium, what did we say happened at equilibrium? We said at equilibrium, if you want to pull the concentration, it will be what? My dear student, at equilibrium, it will be the concentration, equilibrium constant Ka will be the concentration of H plus divided by concentration of A minus divided by what? Concentration of what? HA, or multiply by concentration of A minus. Now, what is the concentration of H plus? Of course, is C alpha. So in place of this HA concentration, put C alpha. Concentration of A minus is what? C alpha also, which is what they have here. Then you now have concentration of HA is in a C bracket 1 minus what? Alpha. Or you can say C minus C alpha to tell you that this is the amount that actually left the total amount you have here. Like that 10k, I told you that you use half of, they gave you half of the 10k. So if you want to calculate the amount remaining, this one now is the undissociated amount, which is the amount remaining. If you want to calculate the amount remaining, it will now be 10k initially you give minus half of 10k the person gave to you. That is the expression we have here. 10k, which is C initially, minus alpha times C, which is the fraction times the initial amount. That is what we have here. Is that okay? Now, at the end of the day, what do you think we are now going to have? C alpha times C alpha, my dear students, is going to give us what? C alpha times C alpha is going to give us C alpha square. True or false? It's going to give us C alpha square. Now, but you may not consider that 1 minus alpha is so small. That means the amount that dissociated is so small. For weak acid, you can consider it, because we say weak acid are substances that dissolve solution to form what? They dissolve in solution, like only small amount of them dissolve in solution. They dissolve only partially in solution. True or false? So can we now say that the 1 minus alpha, that means the fraction that actually left is so small compared to 1. Just like you have 1 and then only 0.0001 dissociated. If you minus 1 minus 0.0, it's going to give us 0.9999. True or false? Now, if you approximate, it's going to give us 1. So sometimes when we talk about for weak acid, it means the amount that is dissociated is so small, it's so negligible compared to the initial amount that was there before. Hence, you now say it is approximate 1. So the amount that dissociated, and 1 minus that half and fraction that dissociated, you say you should also just leave it as approximate 1. Is that okay? So that at the end of the day, you say Ka is equals to C alpha square, right? But you know that H plus is C alpha. I explained to you why H plus is C alpha. I told you that the Ka for this reaction is what? H plus bracket what? A minus divided by what? HA. True or false? Good. So our C alpha is our H plus. So wherever you see H plus, you can put C alpha there. Are you getting it now? So that at the end of the day, when you do your calculation, you know the C alpha is actually squared. It's supposed to be the, okay, this one you have here, C alpha square, right? Now, this one you have here, you can actually make alpha the subject of the formula. How do you make alpha the subject of the formula? It's very easy. If I take this to my board here, now you have Ka is equals to C alpha square. To make alpha subject of the formula, divide both sides by what? By C. This cancel this. So we can say alpha square is Ka divided by C. Right? Now, at the end of the day, alpha will be the square root of Ka divided by C. Alright? So that is what they actually did here. It's very, very easy, right? Alpha is Ka divided by what? C. Is that okay? So that is that. Now, say which is equals to C root of Ka divided by C. Forget about this shit here. Alright? It's still the same thing. Alright, so that is for acid. Now we are going to apply this to solve some question as time progresses. Now for weak base also, it's still the same approach that we took for strong acid that we'll also take for what? For weak base. It's still the same thing. It's very, very easy. Let's see. Alright, now the ionic product of water. Now, when we talk about the ionic product of water, the hydrogen ion is key. It indicates the acidity and the basicity of the solution. Is that okay? Now, equilibrium constant for auto ionization of water. Now, when we talk about auto ionization of water, we are saying that water acts as an acid and also as a base. Are you getting it? So when we're talking about auto ionization, we are saying water acts as an acid and also as a base. Now, how does this happen? Normally, process for auto ionization, you are going to see it as something like this. Now, this H2O will donate a proton to this. This will give H3O plus what? OH negative. You know how, right? Because I told you that this one here, one of them will act as an acid. That means this water here, one will act as an acid while the other will act as a base. So if you look at this very well, if this one acts as the acid, it means this one will donate a proton here. If you donate a proton, what are we now going to have here? Here we come what? H3O plus. Here what will be left? OH minus. This reaction is called auto ionization of water. The word auto means what? Water is acting as the acid and also acting as what? The base. Water is used for the ionization of what? Water. Hence, you call it the auto ionization of water. Now, in the auto ionization of water, sometimes they just indicate it with this reaction. That means one water split to give us hydrogen ion and what? Hydrogenium ion. Because we can also say that hydrogenium ion is equivalent to what? Hydrogen ion. So most times they just indicate it with what? H2O to give us what? H plus what? OH negative. Auto ionization of water. Now the equilibrium constant expression for this will be Kc would be equals to H plus OH negative divided by what? H2O. Now most times I told you that this one does not actually show in the equilibrium constant expression. Water does not show in the equilibrium constant expression because it's a pure solvent. But because of auto ionization, you have to just put it there. Alright? Good. Now, since the degree of dissociation of water is very small, the concentration of water can be considered as, that's what I was telling you, that this water does not actually show in the equilibrium constant expression. Now, at this point in time, you can make water the subject of the, you can cross multiply, use this one to multiply this. So this gives us Kc times H2O will be equals to what? H plus OH negative, which is this multiplied by this multiplied by this is going to give us this. Now this expression is still the same thing as Kw, which is the dissociation constant for water. Is that okay? This expression here, KCH2O, is still the same as Kw, which is the dissociation constant of water, and that is equals to what? H plus OH minus. So whenever you see they put Kw here, Kw is equals to what? H plus and what? OH negative. Where Kw is equals to H plus ion for water is 1 times 10 raised to the power minus 7 mole per dm cube. For OH negative ion for water is also 1.0 times 10 raised to the power of minus 7 mole per dm cube. Hence, if you multiply this, your Kw now will be equals to 1.0 times 10 raised to the power of minus 14 mole square per dm cube raised to the power of minus 6. Multiply this and this. So when they say what is the value of your Kw, it's very easy. Kw is still equivalent to 1.0 times 10 raised to the power of what? Minus 14 mole square dm cube raised to the power of what? 6. Is that okay? Exactly. Alright, so let's see. The ionic product of water can be expressed in terms of pKw also. Right? Now what did you say pK is all about? We said Ka, we have Ka, I will have pKa. I will say pKa is what? Minus log Ka. So if we have Kw, what do you think pKw is? Minus log Kw. Right? So if you have your Kw initially, what did you say was the value for Kw, my dear students? What do you say was the value of Kw? Kw is 1.0 times 10 raised to the power of minus 4. Good. Now, so our pKw will be minus log of 1.0 times 10 raised to the power of what? Minus 4. Which, when you press this your calculator, this is a calculator here. When you press this your calculator, alright, it's going to give us, minus log of this is going to give us 14. And 14 is the correct answer. So from the equation, whenever you hear of pKw is equals to what? 14. Is that okay? It's equals to 14. So from the expression, Kw is always equals to what? H plus multiplied by what? OH minus. You know how we proved this. Is that okay? You know how we proved this. Now they may ask you to prove this in the exam. It's very, very important you know how to do this. Alright, so that is that. Now another expression can be derived by taking minus log of Kw expression. Now what is the Kw expression we have initially? We say Kw is equals to what? Kw is equals to, if you look at what we did initially, H plus multiplied by what? OH negative. True or false? Look at it here. Kw is H plus OH negative. True or false? True. Now, so what do you think will be our pKw? Pkw, if you take negative log of everything here, will be minus log Kw minus log H plus minus log OH negative. Is that okay? What do we say minus log Kw is? We say it's what? The same as what? pKw. Minus log H plus, what do you say it is? It's the same as what? pH. We say pH is negative logarithm of what? Hydrogen ion concentration. Plus minus log OH negative. You see the same as what? POH. So we can say pKw is equals to pH plus POH. So our pKw is equals to pH plus what? POH. Now this pKw, what did we say was the value? 14. So we can also say that pH plus POH is equals to 14. Can also say that pH plus POH is equals to what? 14. It's very easy, right? Exactly. pH plus POH is equals to 14. That's another expression. So the measurement of pH. The pH of a solution is defined as the negative logarithm of the hydrogen ion concentration in mole per liter. I've explained all this before, that pH is equals to minus log what? H plus. Now, if a solution is neutral, the pH is 7. The pH of the blood is around neutrality, but it's not exactly neutral. It's a little bit basic. It's around 7.4. Now, sometimes some persons will say it's between 6.8 to 7.4, so you take the average of this. But generally, neutral pH is around 7. It is acidic if it is less than 7, and it is basic if it is greater than what? 7. Are you getting it? Exactly. Is that okay? So it is neutral when the H plus ion is equal to the OH negative ion. It is acidic when the hydrogen ion, of course hydrogen ion means acidity, is greater than the OH negative ion. And it is basic when the H positive ion is less than what? OH negative ion. Are you getting it now? So that is that. Now POH, based on what we said, POH is what? It's defined as negative logarithm of the what? Hydroxyl ion. And I've also explained that pH plus POH is equals to what? 14, and I've shown that to you. Now you have a question here. Very simple questions to solve. So we are going to create new pages for all these questions. Alright, so the first one is calculate the pH of the following solution at 298 Kelvin, 0.10 mole per dm cube sodium hydroxide. Now how do you calculate the pH of this? Let's see. I think it's 0.10